Hi, my name is Yağız Alp Kuleci. I'm a second year molecular biology and genetics student, and today I'm going to talk about my experiment on angular momentum. In this experiment, I want to investigate how the shape and weight of objects affect their rotational motion. Specifically, I wanted to explore how changing the mass of an object would influence its angular velocity and angular momentum. Let me first explain the materials I used for this experiment. For the setup, I used a stable axis for the objects to rotate on, as well as a rope for the objects to spin on the axis. The objects I used were two wooden cylinders, which one had a smaller radius than the other, and a wooden block, which I will show all later, each of which was attached to a rope. These objects are central to the experiment as I wanted to see how their shape and mass distribution influenced their rotation. In addition to the objects, I used weights of 10 grams, 20 grams, and 100 grams. These weights were attached to each end of the objects. I used tape to securely attach the weights, ensuring they were positioned at the ends of the objects, far from the axis of rotation. This is important because the distance between the axis of rotation and where the weights are placed significantly affects the moment of inertia of the objects. The moment of inertia is a property that describes how an object resists rotational motion. When I attach weights to the ends of the objects, I increase the mass at a greater distance from the axis, which increases the moment of inertia. This means the object will resist rotational acceleration more, causing it to spin slower than it would without the added weights. Finally, I used a stopwatch to time how long it took each object to complete 5 laps. This was necessary to calculate the angular velocity and angular momentum of the objects, which are key concepts in this experiment. To ensure accuracy, I repeated the trials 3 times for each weight on each object, allowing me to calculate average times for each lap. With the object set up, I was ready to move forward with the procedure. Now let me show you the process of performing the spins. For each object, I gave it a push to get it spinning. I then timed how long it took for the object to complete 5 laps. I did this 3 times for each object and wait to ensure I got accurate results. As I performed the spins, I made sure that the rope was secure and that the objects were able to spin freely without any external interference. I used a stopwatch to record the time for each spin, and I repeated this process for all 3 weights, 10 grams, 20 grams, and 100 grams. After completing the spins, I calculated the average time per lap for each object and weight combination. By averaging the times from the 3 trials, I was able to minimize timing error. This is an important step in making sure the data is reliable. The key takeaway from the experiment is how the angular velocity of an object decreases as the weight attached to it increases. This happens because a higher mass increases the moment of inertia, which means the object resists changes to its rotational motion more than a lighter object. So when I added more weight to each object, the object rotated more slowly, and therefore the angular velocity decreased. For example, with the smaller cylinder, I found out that angular velocity for the 10-gram weight was much higher compared to the 100-gram weight. The same trend was observed for the large cylinder and the block as well. Generally, you would expect that as the moment of inertia increases, the angular momentum would decrease because of the decrease in angular velocity as well. However, based on the calculations I performed, the angular momentum actually increased. This is because even though the angular velocity decreased, the increase in moment of inertia was more significant. So angular momentum increased because of the larger moment of inertia despite the slower rotation. One reason for this could be that the distribution of the mass from the added weights contributed significantly to the total of inertia. The more mass that's placed at a greater distance to the axis, the more it influences the object's rotational inertia. As a result, the increase in moment of inertia outweighed the decrease in angular velocity, leading to an increase in angular momentum. This suggests that in this particular experiment, the increase in rotational resistance was more than compensated by the mass at a greater distance from the axis of rotation. One possible factor affecting the results was human error. I performed extra spins to minimize inconsistencies, and since the objects were spinning in the air, some spins could have caused them to swerve unintentionally, affecting the time slightly. Additionally, watching both the stopwatch and the spin at the same time caused me to do some slight timing errors. Repeating the trials helped minimize these errors. For the stability of the weights, I used tape to secure them, but this method wasn't perfect. I had to use a lot of tape to stabilize the heavier weights, which could have unintentionally added extra weight or slightly altered the mass distribution, affecting the results. A more reliable attachment method could have prevented this. Lastly, there could have been minor disturbances such as unaccounted airflow during the experiment, which could have caused slight deviations in the spin. While also doing the experiment, during the spins, sometimes the object would spin out of control or stop completely. These variables are hard to control, but may have impacted the consistency of the results.